All right. Welcome back, everybody. I hope you enjoyed your break. We feeling caffeinated and hydrated and accelerated and all the good things? Awesome. So the next presentation will be co-presented by Sophia T. and Alex F. Timyadis. So Sophia is the Director of Data Science at Penguin Random House, and Alex is the data scientist also at Penguin. They're going to talk about using automation and machine learning to advertise at scale. Okay.
Thank you. Good morning, everyone. How's everyone doing today? Awesome. Well, as you mentioned, my name is Sophia T. I am a Director of Data Science at Penguin Random House, and here today with me is Alex F. Timyadis, who's a machine learning scientist in my team. So today we're going to talk a little bit about advertising at scale. Oops, let's see if this works. If this works. Oh, there you go.
There we go.
All right. So why is advertising at scale so important, you might ask? Sometime mid last year, we began conversations with our marketers about how to drive more online conversions through the different ad platforms that we're using. And one thing that became really apparent to us was that in order to do that, we needed to be able to do widespread testing across our ad platforms. And that is a little bit more challenging as it may seem, because right now, the way they're doing it is extremely manual. So say, for example, you're a marketer that was trying to market a book by David Grann, The Wager. You would have to talk to several different teams in order to get that done. So you'll have to talk to, say, the copy team to get the right messaging across. Then you have to talk to the creative team to use backgrounds that make sense for the title. And then finally, you have to talk to someone like the publisher or the publicist, as well as sometimes the author, to figure out what is the audience you want to target. And say you were a marketer that was doing that for not just one title, but for multiple titles every single day, 365 days a year. Oops, sorry. So here's what, this is just a toy example of what the data science team had in mind. So say you had two different types of artwork, two copy, as well as two audiences you want to test out with. Mathematically speaking, that gives you 8 different permutations of the ad. And as we mentioned before, this can be actually a lot of work if you're going to do it manually. So what data science had in mind was automating this entire campaign loop so it will not be as taxing for our marketers. And there are 4 different streams of work. So we have audience generation, creative generation, copy generation, and then finally actually creating the code that feeds all of this information into the Facebook UI through the API. So we're going to focus a little bit more on creative generation and copy generation today, but just to touch lightly on the audience generation piece. So what we're doing is we're using our PRH.com first-party data and essentially building a recommendation model that then creates a candidate audience for us to upload into the Facebook UI. And then finally, the Facebook UI code basically takes all of that information and parses it through to the API automatically. Sorry about that. So with creative generation, with 2 types of main backgrounds that we have. So we have what we call our universal backgrounds. So essentially, it can be used for any sort of title, be it whatever genre or age group that it's targeted to. And essentially, what it does is, using CSS script, we identify exactly where the book is within each cover image, each background. And then we dynamically switch out these cover images because essentially we have a URL with all the cover images that PRH has. And all we have to do is change out the isbin in the URL code. So it's extremely dynamic and very quick for us to do that. The second set of backgrounds is essentially specific to certain age groups and genres and seasons. So as you can see here from left to right, you have an elementary school book background, and you have a romance novel background, and then you have something that's specific to Halloween. And now Alex is going to bring us through a little bit more about how we're thinking in the future about this creative generator problem, how we can do the positioning of the book within the background in an automated way. So take it away.
Sure. So, yeah, so far, as Sophia has said, we've been kind of manually determining the position and orientation of the book on the background to superimpose a new book and reuse old ads. This works pretty well. We have a few hundred of those, but ideally we would like to be able to do this automatically. And at first glance, it looks kind of like a classical image detection problem. You draw a box around the book and superimpose the new one on top of it. But there's actually a little bit of novelty to this problem, because it's not just about drawing a box around the book. These books are taken at arbitrary viewing angles. So we have not only the actual box around the book, we have the rotation of the book and the perspective at which we're viewing the book. And ultimately, this can come down to determining 3 of the 4 corners of the book. You could think of it as one corner determining the location, the other 2 determining a linear transformation that gives you a new perspective, or the one that that particular book was taken at, relative to a straight-on shot. So if we took a picture of a book, the book cover taken at a straight-on angle, the way we do, as Sophia mentioned, for all of our covers, we could determine from those 3 corners how to superimpose it on an old book to cover it exactly. Now, like many problems in data science, while there exists lots of models that are perfectly suitable or easily modified for this task, there's YOLO and things like that that we could modify to spit out 3 of the 4 corners as opposed to a bounding box. We don't have a lot of training data that has, at least not labeled training data, of books superimposed on backgrounds with labels determining where the 3 corners are, or equivalently where they are along with position and orientation. So how do we get enough training data to actually train an algorithm? That's the challenge. Now, one thought we had was, well, we have this nice web development stack-based program that can superimpose books on backgrounds at arbitrary viewing angles. What if we hijacked that to superimpose random books on random backgrounds at random positions and viewing angles? We could get a lot of examples of books on backgrounds, but with predetermined viewing angles that we could use as training labels. So by randomly generating a bunch of books on backgrounds with random but predetermined positions and orientations, we could build a pretty large training data set for an algorithm like this. And it turned out that the main pitfall in this, or at least the main challenge in this so far, has been a discrepancy between the coordinates that the CSS, JavaScript, HTML stack expects and uses, and the ones that our Python-based machine learning stack would ingest. So if we tell the CSS JavaScript framework to superimpose a book, it's not quite that bad, but. Okay, better? Closer. Okay. Yeah, so if we where was I? So we superimpose the book on the background with a predetermined set of coordinates with the CSS, JavaScript, HTML stack. If we try to tell Python to draw a box around that book using those same coordinates, the box will appear a little off, and not in a consistent way so far. So that's actually more of an engineering challenge, a discrepancy between CSS, HTML, JavaScript land and Python land. So that's the main challenge with that, but it might be a promising approach still. If I can go forward, we have another approach. There we go. Yeah, so there's another more sophisticated image processing technique that'll encompass, or that'll suffice for this problem called image segmentation. And the general idea is to be able to draw pixel masks around arbitrary portions of objects. So for example, you could draw pixels around faces, hair. A lot of times this is used in the automotive industry to find cars, traffic lights, stop signs, pedestrians, things like that. And obviously this is going a step further than just figuring out the position and orientation of the book. This is determining what pixels make up that book in the picture. And to be able to do that, as you might have guessed, you need much more sophisticated training data. You need to be able to draw an object or an arbitrary polygon in general around where the book is. And this will account for situations where the book's occluded by another object or another book. But it's also a fair amount of manual work to draw polygons around the books, even using tools provided by AWS and things like that to help speed up the process. But this would be a way to use classical image processing techniques on our problem, even if they're a little bit more sophisticated than exactly what we need. So with that, I'm going to turn back to Sophia.
Is this okay? Testing. We're safe now. All right. Can I have this? Thank you.
Yeah.
All right. So as I mentioned before, with our third-party vendor, we're essentially automating our copy. And these are all examples of automated copy as well as creative. So all this came from our automated system. And we're pretty happy with most of the copy that we're getting. But now I'm going to go through some of the limitations that the marketers have identified with this AI-produced copy. So in this book, I have some questions for you by Rebecca Mackay. We have 2 different sets of copy. And the main criticism for this is that essentially the AI-produced copy is making multiple references to a character which is somewhat obscure. So it's a character that I don't know if any one of you have heard of, but it's Bodie Kane. It's not like a Jack Ryan or Alex Cross, like a recurring series character. And then the second criticism is the fact that, especially in copy 1, as you can see, the text is very long, so it may not be ideal for a Facebook ad. In this book, Cary Grant's Suit by Todd McEwen. So you would notice if you go to the product detail page at penguinrandomhouse.com that this text that is so-called attributed to Ian Sampson is not actually an endorsement by Ian Sampson. In fact, what the crawler has done is push together 2 pieces of text from different parts of the product detail page into one. So it's definitely not what we want to do, attributing things that do not belong to someone. And addition to that, Ian Sampson from The Telegraph is actually in the UK. And since we are targeting books, people in the US, we definitely don't want to do that. For this book, Our Bucket List Adventures, you would see in the text given by our AI that it's coding a quote-unquote reviewer. Again, very generic, clearly not an actual person or publication. And in addition, if you look at the product detail page, you would notice that it's actually just a product description. This book, A Cook's Book by Nigel Slater. So it's kind of nitpicking, but essentially the criticism was that it's missing an open quotation mark in the text field. And in addition, it's not attributed to an actual person. So for Facebook ads, we definitely want to be very precise, very on point. So where does that leave us? So we've talked a lot about automating the copy and how we want to optimize all of the copy and creative as well as audiences. So Alex is going to talk a little bit about how we're going to evaluate and maximize the ROI once we have all these tests in place.
Yeah, so first of all, I'm going to start with a little disclaimer about the data being representative, because we could do some A/B testing in the spring, and we can always question whether it's going to still hold true in the summer. We can do A/B testing for romance novels and wonder whether it's going to hold true for memoirs. There's all kinds of questions that you can endlessly dive into about whether data is representative, and I'm not going to go too far into that because that's so domain specific and so open to question. And in the end, more testing is better, and you just have to, if you want to raise new questions, then you raise new experiments. But if the data is representative, what can we say about it? That's the main question. So I'm going to simplify things for a second. Imagine that we have only a few possible click-through rates. Now, why are we doing this? Now, if we show an ad to 10 people and 7 people clicked it, empirically the click-through rate is 70%, but doesn't mean that 70% are always going to click that ad forever. The click-through rate may have been 20%, and we just got really lucky. Or it may be 80%, and a couple of people missed it. And if we kept trying it later, more people would click the ad. So the question is, what is the actual click-through rate given the data we've seen so far? Now, imagining for a second that there's only 5 possible click-through rates. I know this is not the case, but I think you'll see how this generalizes relatively straightforward, in a relatively straightforward manner. So there's 5 possible click-through rates shown here. We've seen 3 of 5 people click it. Which one is it? So this is kind of analogous to drawing marbles out of a jar, where there's going to be some number of red and green marbles in the jar, and you don't know what proportion it is. But if there's only 5 possible jars and you draw a red marble, you know it's not the 100% green marble jar. And if you draw a red marble, you know it's not, or a green marble, you know it's not the 0% green marble jar. So you can say something. And in general, there we go. You can use Bayes' theorem to figure out the solution to this kind of problem. Preferably that slide. Yeah, so you can use Bayes' theorem to try to figure out the likelihood that you're looking at each of these jars, given what you've drawn so far. And likewise, if people click or don't click the ad, you can use Bayes' theorem to figure out which of those 5 possible click-through rates you're actually looking at, if those are the only possibilities, and assuming that they're each equally likely to start. Key assumption there. But you can, of course, change that prior accordingly. So this generalizes to arbitrary click-through rates in what's known as a beta distribution. So if you want to have any click-through rate between 0 and 100%, you have no idea which it's going to be until people start clicking. There's a pretty well-established way to backtrack and figure out, given the number of people that have clicked and not clicked the ads, what the probability is of the true underlying click-through rate being any number between 0 and 100%. Now, this gives us a nice probabilistic way to view ROI, because assuming ROI is proportional to click-through rate, there's going to be some probability that each of those click-through rates is the one that governs the ad you're looking at, and there's going to be some distribution over possible ROIs. Now, how does that help us maximize ROI? Well, it's a step in that direction, but it's not all the way there. So far, all we know is that there's some distribution over possible ROIs, and we can get increasingly certain what that is as more people click or don't click the ad. The question is how we're going to allocate budget accordingly, given the information we have so far. And in academia, we would be looking at kind of what's called a multi-armed bandit scenario. So the classic analogy here is that you have multiple slot machines, and you're only allowed to pull one at a time, and you try to figure out which one's going to pay out the most as quickly as possible without spending money on the ones that don't. In a similar case here, we have multiple ads, and we want to figure out which one is going to give us the highest ROI without spending too much money showing the suboptimal ads to the audience. There's a couple of classical approaches to this. The epsilon greedy strategy would be where we show the ad we show all of the ads to lots of people uniformly. So we give each ad $1,000, and once we're sufficiently certain that one ad is better than the others, we just switch over to that one from then on. A more nuanced approach would be what's called Thompson sampling, where we allocate the budget according to the probability that one ad is better than the other. Now, I've glossed over a little detail on how we actually determine which ad, or what the probability is that one ad is better than the other. So far, I've discussed how we determine the probability of the ROI being one number, or at least a greater than a different number, based on the probability distribution over the click-through rate. Since each of these ads has a beta distribution associated with our certainty that the ROI or click-through rate is a given number, we can sample from that and basically say for each of these ads, here are some possible click-through rates that they could have, and figure out empirically from that Monte Carlo simulation how many times ad 1 samples a click-through rate higher than those sampled from ad 2 and ad 3 and so forth. So this allows us a way to figure out the probability that one ad's click-through rate or ROI is higher than another ad's click-through rate or ROI, given the probability distribution over each one's click-through rate or ROI respectively. And from that, we can determine strategies to allocate budget accordingly. So the more nuanced Thompson sampling approach would allocate a budget proportional to the probability that that ad maximizes click-through rate or ROI. So in this sense, if one ad was very unlikely, was doing pretty poorly and maybe had a 0.001% chance of actually being the winner, we'd actually never really retire it. We would just pick it 0.001% of the time randomly. And the nice thing about this is if, let's say we were testing summer ads and winter ads and it happened to be spring and it looked like the summer ads were doing better, we would naturally pick winter ads less often. And as time went on, maybe in the fall, we would pick winter ads, maybe we'd only be picking winter ads 10 or 5% of the time because there's a very low chance it's actually going to be the one that would maximize our revenue at the time. Maybe in the fall they'd start to pick up again, and since we're still picking them sometimes, we would get some more data that could counter our earlier data and allow us to naturally switch from one to the other. I'm not saying we necessarily do it that way, but if the circumstances change, this would allow us to kind of seamlessly switch between different scenarios that matches the data distribution we're seeing today. Yeah, in the future, we're looking to automate, expand to other ad platforms where we can, outside of Facebook and Instagram, for instance, maybe into Amazon. We would like to encourage more widespread adoption and, with the help of marketers, elevate and improve the quality of the output. We'd also like to expand to multi-title campaigns in which we would have creatives that have multiple books featured in them at once. This is obviously a more sophisticated image processing problem in that we have to find multiple oriented bounding boxes around multiple books, but that would be a goal for the future. And of course, as I've mentioned, testing different seasonality and trend conditions is important. At that, maybe we can turn it over to questions.